Hello, so today is day 2. It's a review of rates, ratios, proportions, percents, and percent change. It is all based on the same information where you are cross multiplying. It is just possibly different skills. So, in this, when we're talking about a rate is just one fraction. So it's a conversion, but rates are written as fractions. So if we look at this, so when we go down to our examples, okay, we're trying to convert one thing from one thing to another, and we cancel out units. So if we want to write this as feet and yards, there are 3 feet to every 1 yard. They're equivalent, they're just in different units. Okay, so meters to centimeters. There's 1 meter is 100 centimeters. Okay, there are 8 fluid ounces in 1 cup. All those fractions are equal, they're just written in different units. So what we do is we use those to convert from one unit to another. So in our next example, we have that in the Tour de France, 3,391.1 is 3,391.1 kilometers, okay? And Lance Armstrong won it in 83.5 hours, okay? So we want average speed in meters per hour. So we start off with our original, which is just a fraction, okay, kilometers over hours, and we use that. But now we have to convert it. So we want meters, okay, instead of kilometers. So what we do is, to cancel this out, we need to put a kilometers here, because if we're multiplying, we need to cancel out that multiplication, we need to divide. And if you know the conversion, 1 kilometer is 1,000 meters. So what happens is this and this cancel. So the only units left are meters and hours. So then I multiply. So 3,391.1 times 1,000 is 3,391.100. Okay, I'm moving this decimal place over 3 times, and I'm keeping the 83.5 the same. So now I just convert it. So what I would do is I would just divide these numbers. Okay, so now I get my unit rate is 4,061.2 meters per hour. Okay? So I would do the same thing for number 5. Okay? So I start off with 1,200 gallons per hour. Okay? So 1,200 gallons per 1 hour. Okay? And I want this rate to cups per minute. All right? So I need to change both of these. So what I do is I multiply by another fraction. So let's convert to minutes first. Minutes, okay? So if hours is on bottom here, I need an hour up here. So I know 1 hour is 60 minutes. Okay? So then I multiply by another fraction, because I know these hours are going to cancel because one's on top, one's on bottom. Now I need to use this. 1 gallon is 16 cups. Okay? So I have gallons on top here, so I'm going to multiply by another fraction. So 1 gallon is 16 cups. Okay? So now with that, I can cancel out my gallons. So now I multiply everything on top. So I do 1200 times 1 times 1600, or 16. So 1200 just times 1 times 16 is 19,200. And 1 times 60 times 1 is just 60. So then that's cups in hours. So now I just divide that and I get 320 cups per hour. And that's how I do unit rates. I'm just canceling out the units by multiplying by more fractions. Now, things are different when I have two fractions. When I have two fractions that are equal to each other, they're called a proportion. And when there's a proportion, I cross multiply and I solve. So in these examples, I cross multiply and I solve. So we've done these before. So 8 times x is 8x equals 20 times 1, which is 20. I divide by 8. X equals 2.5. Again, I do the same thing. 5 times k is 5k equals 12 times 1.25 is 15. I divide by 5. K is 3. In these next ones, there is a plus sign or a minus sign. So what I do is I still cross multiply. So I still do 3 times 21 equals 4, but now I put parentheses around it, a plus 5. Now, if I do that, I have to remember how to distribute. And distributing is just multiplying. So 3 times 21, I'm going to do that. That's 63 equals 4a plus 20. Now I subtract my 20 from both sides. I got 43 equals 4a. Now I divide by 4. And I get a equals 10.75. I do the same thing every time I see a minus. 9 times 3 is 27 equals 1 times y minus 3. 1 times y minus 3. Well, when I distribute in the 1 times anything is just that same thing. So it's just y minus 3. Now I'm going to add 3 on both sides. I got 30 equals y. And I'm done. So that's how I deal with proportions. So for these problems, again, these are the listed problems that you do. So what I want you to do is 2 of the top 4, 3 of those middle 6 problems, and do both of those 11 and 12. And then for these problem solving ones, same thing, do 2 of those top 4 and 2 of those bottom 4. When we get to percentage, we just do proportions. And we have talked about this. Part over whole equals percent over 100. You also know this as is over of equals percent over 100. So I just set up the proportion. Okay, so 14 is what percent of 56? Okay, so which value is the whole part? Anything that follows the of. So the 56 is the whole part. Which value is the part here? The part is the is. Okay, so 30% of what number is 12? The is 12. That is means it's the part. Okay? And the percent is always the easiest to find. It's the number with the percent, so that's the 20. Okay? So, I'm going to skip these bottom ones here, and I'm just going to go to 7 and 8. 7 and 8 are where we are solving. So 40%, that's a percent, of what is 16. So the is 16 goes on top here. I have an equal sign. The percentage, then 100 is always underneath the percentage. And it says of what? Of what means that's the variable. That's. Now I cross multiply. I got 40x equals 1600. I then divide by 40. X ends up being 40. Okay? In this case, what is, so I don't know the is, 75% of 200. So if I set up my is over of equals percent over 100, my is I don't know, so I'll make that x, over my of is 20, equals, the 100 is always there, and my 75 is my percentage. I'm then cross multiplying, so I have 100x equals 1500. I divide by 100, which means I'm just going to cross out those zeros, and x equals 15. So that's how I work with percentages. We've done this before, but we need to remember this for all of our math classes moving forward, because percentages are used throughout, even in chemistry. Now, there's another way where we can create an equation and do the same thing, where we write it as a percentage as a decimal, and the part of the of is times that percentage, and the is goes here. So it goes percentage times of equals the is. Okay. Now, oftentimes the students will like this. The problem is when converting a percentage to a decimal. So when we convert to a decimal, remember percentages. Okay, to move percent to a decimal, move the decimal point twice. Okay, so you can see that 4% has a decimal place here. Okay. So if I'm moving the decimal place, I put 4, I have the decimal place, and I move it twice. 1, 2. Anything that is open, I put a 0. So you notice this gets used right there because that is percentage as a decimal. Okay? You'll notice here I have 0.72. To convert it to a percentage, I move it twice. So it becomes 72%, and that's how I get my answer there. Okay? So I'm just going to help you set up these. You do not have to do this all the time, but it is good to remember how to convert percentages to a decimal. Okay? So 7 is... So 7 goes where the is. 20%, the decimal place is here. So what happens is I move it twice. So it becomes 0.2, 0. You can write the 0. You don't have to. Of what? I don't know, because the of is what, so that's my x. So this would translate into 0.2x equals 7, which then, if I wanted to solve it, I would divide by 0.2. X would end up being a larger number. Now, when I am dividing by a decimal, the number gets bigger, so my x is 35. All right. For number 6, what number is? So I don't know my is, that's my x. 50%, move that decimal place over, 0.5 of 92. So this just translates into 0.5 times 92 equals x, which ends up being 46. Okay? I'm going to skip these bottom ones. I want to do 9. What number is? What number is? That means my is my x after the equal sign. 140% means the decimal place is here. I move this decimal place over twice. This becomes 1.4 times 25. So all that's saying is 1.4 times 25. So my x is 35. And I don't have to cross multiply. In this case, for 10, what percent? So I don't know my percentage. So that's my x times of 28 is 1.4. So now I'm solving an equation. I'm multiplying. Now so I'm multiplying, divide. Okay? So I do 1.4 divided by 28. I get x equals 0.05. Now, 0.05 is not a percentage. So I have to move that. So 0.05, I move the decimal place the other way. So that becomes 5%. The decimal place there. Okay? So those are two different ways of solving percentages. You can do one or the other. So this is the same thing, cross multiplying and dividing. More examples here. These are all examples that you can follow as part of your notes. Now, percent increase and decrease is the same thing except for you have to do one more step. So, if I'm finding the percent change, you'll have two numbers to start with, okay? And you always have to find what that change was. So, if it's changing from 75 to 90, okay? So, from 75 to 90 means it went up 15, okay? So I'm trying to figure out what that change is to go up 15. So in this case, I do new number minus old number over old equals percent over 100. So we always use kind of the same formula. Okay? So in this case, we would do the new number is 90. All right, so I'm going to do this one over here. So 90 minus 75 over our old number. So what did we start at? We started at 75 equals percent, I don't know, over 100. Okay? So then I do 90 minus 75, which is that 15. So that 15 is right here. Okay? So showing that it went up 15. Now I can cross multiply and solve. So when I cross multiply, I get 75x equals 1500. I now can divide by 75. And I get my x equals 20. So find the percent change. It's a 20% increase. Okay? It went up 20%. Up 20%. Okay? Now, for number 2, you'll notice it's going from 140 to 84. So now it's going down. I do the same thing, okay? New number is 84. Minus the old number is 140. Over my old number, which is 140, equals x over 100. Do the subtraction. So 84 minus 140, it's going to be negative. And that's okay because it's going down. So negative 56 over 140 equals x over 100. Again, cross multiply. I get 140x equals negative 5600. And now I divide by 140. And I get my x equals negative 40. So that means number 2 went down 40%. Okay? So it's a decrease of 40% down. So 40% down. So when you move on, and again, there's lots of notes on this, all up in here are extra notes that you can always reference. Don't do these top 9, but I want you to try 4 of those 8 and do both of those word problems. After you're done with that, these again are notes on percent decrease, okay? Only now they're giving you costs of things. So a cell phone is on sale for $76. It's the same setup. So we're just trying to find out what that percent increase or decrease is. So do 2 of these 4 and 2 of these 4 as those percent increase and decrease. And then after you're done with all of that, this is your rates, ratios, proportions, and percents assessment. After you're done with this, you're going to move on to day 3. Thank you very much, and make sure you check your answers on Google Classroom.